Okay, so I am Professor Graham Watson. I am the Science Course Director. So I'm in charge of coordinating the science programme at Trinity College, and hopefully you're all here to hear about science. Otherwise we just turned some people away who could have got in. Anyway, my role is to really manage the Science Course Office, which is the place that coordinates the science programme, and it primarily works on the TR071 course, the Common Entry course. That's where most of the science students in Trinity come in. And it coordinates the programmes through the different disciplines and subjects. Science is a wide range of subjects, so we work with the physicists, the chemists, the biochemists, the zoologists, the physiologists, the geographists. All of them coordinate their efforts towards the science programme, and it's the Science Course Office that does that job. So we handle student course registration, module choices, assigning people to different labs. We can't stick 340 people in a single chemistry lab. We don't actually have a lab that big. So we do all of those things and give the information to the students and coordinate the programme. We also keep the course up to date and relevant and collate feedback between staff and students. And the Science Course Office is really the contact point for the students, and that's actually very important in a course like science, where there's a lot of choice and a lot of decisions to be made. And so students can come into the Science Course Office and discuss those choices, and I'll go through some of those choices in a moment. And essentially it's a contact point, a single point of contact for the students. We also have a web page. It's starting to look a little bit dated, I have to say, and we actually are in the process of updating it. But in here you'll find lots of information both for prospective students, but also it's the place where we distribute information directly to the current students. It's in terms of things like the programme booklets, the course module descriptions, and all of those sorts of things, exam regulations. So we use it for multiple purposes. So hopefully this slide isn't too hard to sell. Why study science? Okay, science, the technical and scientific knowledge that you gain doing a science degree is actually very important in the modern economy. Okay, so there's lots of jobs that directly use the technical and scientific knowledge that you gain within a programme like science. But in addition, there's this sort of the not so tangible qualities, analytical, logical and critical approach to thinking. Okay? Science teaches you a way to look at information, to process that information in a logical and an analytical way, and to come to conclusions. Okay? It's not about digesting lots of data and regurgitating it. That's not what the science degree is about. It's about how you look at data, how you process that data within the context of the scientific subject that you're looking at. So students will also be trained in different ways of working. There's obviously a lot of individual work in actually getting to grips with the science subject. We also have teamwork in terms of putting together, say, presentations as part of a team, or other teamwork which builds those sorts of skills that industry is often looking for. The modern environment is always changing, and scientific skills are becoming increasingly important in a broad range of areas, not just for developing new technology, but for things like policy making or humanitarianism. So scientific knowledge is impacting on all of these things, and a good grounding and approach to these types of subjects is very important in the modern world. Consequently, there are a huge number of career opportunities opened up by a science degree, both the technical and directly scientific based ones, but also the ones that require some of the other skills. And I put up a slide like this every year. It's so varied in terms of the careers that people from the science course at Trinity have gone into that I'm not actually sure it's that helpful in a sense, because we have some of the direct ones: pharmaceutical industry, zoo and wildlife management, chemical and pharmaceutical sectors, toxicology, sort of all these things that are directly related to the science subject, but we've also got business, finance, telecommunications, IT, teaching, I don't know what else we've got, health and safety. So lots and lots of things which are not necessarily directly related to the science subject that's actually been looked at. So, you shouldn't do that in lectures, but I'm actually going to check mine's off now. It was. So, hopefully you're all here, so you're interested in science. I guess the second question that I've got to convince you of is why study science at Trinity? What makes Trinity different to any other university? Well, Trinity has a very high number of research world leaders in their particular fields, and those researchers are part of the teaching program at Trinity. So teaching is research-led, as it's termed, and it's by many of the people who will teach students here are world leaders in their field. Now, you might say that perhaps that's not as unique as I'm trying to say. Well, what we do at Trinity is everybody is involved in the teaching program. If you go to some of the world-class universities around the world, you will find that there are some very high-profile research leaders, and they probably have nothing to do with the undergraduate teaching program. In Trinity, everybody contributes to the undergraduate teaching program, so whether you're the director of the Nanoscience Institute or you're the director of the Neuroscience Institute, you will be involved in the undergraduate teaching of students here. We have excellent lab facilities. It's a bit hard to see, but if you go down the far end of the atrium, where all the subject stands are, where you can get detailed information about the subjects, there are actually the chemistry and biology undergraduate teaching labs sort of behind the stands on this side. So there are quite extensive facilities, because science, after all, is a very practical subject. Trinity is very highly placed in the global ratings. Now, whether you believe exactly how the global ratings are calculated, it doesn't really matter. What the global ratings show you is that Trinity does very, very well, particularly in how it's perceived, okay? Both within Ireland and also outside of Ireland. It's the top Irish university in the global rankings, and that gives you more flexibility in terms of what you do with your degree afterwards. One of the things we maintain within the science program at Trinity, which is essentially something we protect, and certainly a lot of the other universities have not, is that we insist on each of our degree subjects having a detailed research project as part of the program. And in that, students will be given topics to research and given 8 or 10 or 12 weeks sometimes to actually research that topic with some supervision from an academic, but to actually get to grips with something that's never been looked at before and develop those sorts of inquisitive skills. Field and laboratory work are ingrained within the entire program as appropriate for the particular subjects, and as I've already said, in terms of the science course office, there's a dedicated and thorough administrative support for the students to make sure that they're getting, or at least they're doing the sorts of courses and not having problems in terms of their university education. We're continuously updating and revising the course to try and ensure that the quality of the qualification is there, but also that the relevance of it is there to the modern world. Trinity itself has a tutorial service. In that tutorial service, every student is allocated a tutor, and essentially within that is quite unique in the sense that person becomes the advocate for the student in dealing with college. Okay, so if there are problems, and 75% of students never really need to call on their tutors, but if there are problems, then that person will essentially represent you within college to make sure that you're fairly treated. They can also give you advice about various aspects of the university, and also they can be a confidential point of contact if you're having problems outside of university that are actually impacting on your university education. And then they can be dealt with. The other thing about the science course, which I'll spend some of the time talking about in a moment, is that there's a wide range of options. In fact, there's so many options, it actually gets rather complicated to explain it, and I will probably confuse you in the next 10 minutes to some extent. There's lots and lots of options. The idea is that you come into a general science intake, that you work out while you're here what actually interests you, and then you can specialise in it within the 3rd and 4th year of the degree programme. So, what am I actually talking about? The main thing I'm talking about is this TR071 Science Common Entry. Okay, 340 students come in through this programme. I don't actually, as Science Course Director, I don't actually deal with the maths and the theoretical physics. They're done separately. But these courses are what I refer to as direct entry science courses. They are human genetics, chemistry with molecular modelling, medicinal chemistry, nanoscience, which is the physics and chemistry of advanced materials, and earth sciences. Now, I deal with those partly because all of these programs are effectively you're selecting your 3rd and 4th year subject early. That's all it is. In the 1st and 2nd year, these courses follow modules in the science course, just a specified set of them. So there's no choice with it, well, there's little choice within these programs. So, in terms of the science, you come in, obviously your specialised subject has not been determined. These are the specialised subjects that are available, and students will do 2 years of general science and then choose one of these. Okay, so we've got biochemistry, chemistry, environmental sciences, functional biology, genetics, geography, geology, immunology, microbiology, molecular medicine, neuroscience, physics, physics and astrophysics, physiology, plant sciences, and zoology. Now, the thing I like about this structure is that most 17-year-olds looking at this set of subjects, even if they think they know what, say, chemistry is, they probably don't in terms of the university context. So choosing specific subjects at this point is actually quite difficult for people, and many people who do that then end up going, that wasn't really what I wanted to do. And so the science course offers the opportunity to come in and try some of these things out, and then in the end of the 2nd year choose one of the specialisations with a much better informed choice. They are the 1st year modules, so I said this was general in the first 2 years. Essentially, we have a whole set of modules. These are the 1st year modules, and you choose 6 of them. Okay. Now, it's not particularly easy to see which 6 you would choose. So, in a moment, I'll give you a little bit of a structure of how they're organised and a few patterns in which lead you to particular degree areas, just to show you what sort of subjects. Before I do that, I just want to look at the structure of the year at Trinity, so the semester structure. So basically when we start in September, there's a 1-week induction day, 1-week induction, and in that you'll have induction into the course, but also there'll be all the student societies. The hundreds of them will be touting for your membership. After that, we have 6 weeks of teaching, which will then be followed by 1 week. The light is not very good here, so I might actually turn the light down. Oh, it's already turned down. A bit more. Okay. So we have a 1-week study week. In this, students are supposed to be catching up on their work, making sure they understand everything, so that towards the end of the semester everything doesn't go pear-shaped. Now, the first week they introduced this, I did ask to speak to a student who told me they were on a skiing trip, which didn't go down well. That's not really the purpose of it. Anyway, after the study week, we have 5 more weeks of teaching. It's a 12-week semester with a 1 week in the middle-ish. Then we have the Christmas vacation, and then we do the whole thing all over again. Then we have 3 weeks of revision, followed by a 4-week exam period, and then some time for the academics to mark it. And what I really want to say is that that 4-week exam period there examines all of the material taught in both the first and the second semester. There are no semester exams in Trinity. Okay, we only have annual exams. So the course is spread out across these 2 equivalent semesters, and basically we have a set of modules that are available in semester 1 and a set of modules that are available in semester 2. For some of the subjects, if you want to take the one in semester 2, you have to take the one in semester 1. That's true for maths and physics and chemistry. For the others, it's not actually true. You can take any combination. So we've got all these modules. So what do you pick? Well, we have 4 patterns to try and explain the sorts of choices that people will make. So pattern 1 includes maths in both semester and physics in both semester. Now, if you choose this pattern, you've got 1 more from each of these boxes. So you can take chemistry, biology, or geography, and in the second semester, chemistry, biology, geology, or geography. If you choose this pattern, then obviously you can go on to physics. That's quite obvious. You can go on to a number of other things: chemistry, functional biology, geography, geology, physics, physiology, plant sciences, and zoology. But it depends which of these you actually take. You have to do appropriate subjects for the specialisation you want. So if you want to do chemistry later, you obviously have to do first-year chemistry. That part's not rocket science. The part that's closer to rocket science is trying to work out which combination is best for you. Sorry, I should say it's not recommended for biochemistry, immunology, molecular medicine, or neuroscience. And the reason is that these ones require you to do first-year chemistry. Technically, they don't actually require you to do first-year biology, despite it being rather biological orientated. But that's the requirements for those courses. You can't take genetics or microbiology because you need to take biology and chemistry in first year. So they're the sorts of decisions you have to make. They're quite complicated. I'll quickly run through a few more because probably the only thing I will do in doing this is actually confuse most people. And I'll explain how we deal with that confusion in a moment. So if we do full maths in both semester, you get a wide range of choices. This is a very popular pattern, and consequently, depending on what subjects you can take just about anything. You obviously have to take the prerequisites, the modules that are required to study a subject later on. So microbiology requires you to take both chemistry modules and the first biology module. What you can't take is physics. Pattern 3 has just 1 semester of maths. You can see how the patterns were constructed here in terms of the maths requirement, really. And again, you have a wide range of choices because all of the subjects except physics only require you to do 1 semester of maths. Okay? So you can't do physics again. Pattern 4, the last one, has no maths in it. Not a recommended pattern. There is only 4 subjects that you can actually take without having studied maths at university. They are environmental sciences, geography, geology, and plant sciences. And my recommendation is that there's no point in coming into a general science course and then restricting yourself from day 1. So you should leave yourself open as many options as you can. So they're all the ones you can't do. Now, as I said, what I've probably done is confuse everyone. It is confusing the selection of modules. And you also then have to select your second year modules at the end of first year. The reason it's complicated is that we try to build in as much choice as we can. And the more choice we build in, the more complicated it gets. But the more flexible it is for students to actually study what they want to study, or try things that they didn't think they would like, and suddenly discover a new area of science that they're interested in. It looks daunting, but the other thing is, particularly through the Science Course Office, we have a lot of experience of this, but also we provide a lot of advice to students on an ongoing basis through their degree program to try and make sure that they are actually doing the appropriate modules for them. And I guess the most obvious one is in the initial orientation. In Freshers Week, we actually have an induction day for science students. We have talks from the various subjects to explain what their subjects are about. And then we have one-to-one meetings with every student. An academic meets on a one-to-one basis with every student in the science course to discuss their module choice. Okay? And what they will ask, they'll ask what you did in Leaving Cert, they'll ask what you're interested in, which degree subjects in the third and fourth year you think you might be interested in, and then they'll discuss the module choices and the options that it leaves open for you. And the idea there is that they will try and obviously advise you on the modules that leave open this widest range of subjects that they can, while ensuring that the areas of science that you're interested in are covered by that. So we make a lot of effort to try and get this right. And in addition to which, if people suddenly find that they've signed up for, I don't know, physics, and 2 weeks in they realise that it was a major mistake, then within the first few weeks we let people move between modules in case they make that mistake. And also the second semester modules can be changed up to the end of the first semester. So if you've signed up for maths in both semesters and halfway through the first semester maths course you realise that that wasn't a particularly sensible idea, you can finish that maths module to make sure all of the subjects are open to you, but then essentially duck out of the second semester and go and do something else. So we allow that flexibility within the course. And the advice is always there in the Science Course Office at any time. The Science Course Office actually is just down the atrium as well. So there's a door directly off the atrium, and students can come and see us if there are any issues with the course at all. The dreaded points. So this is the historical trace of the points for science. They're pretty high, 505. For anyone who doesn't know, you've probably been scanning through the CAO forms like nobody's business. You probably passed the exam on the CAO form by now. 505 star. The star means there was a lottery essentially for the final places. So not everybody on 505 actually got into the science course. Science is reasonably stable. 340 places makes the statistics such that it is quite stable in terms of the points cut-off. The increase between 2011 and 2012 is the bonus points in maths being introduced. So there's 25 bonus points for maths, and you can see it went up by 30. So most of that is to do with the bonus points in maths. The direct entry courses have much fewer places, and so the points tend to be much more variable. Probably the biggest variation we've seen is nanoscience here, which 4 years ago, it was actually called something different then. It was 410, it's now 570. Okay? And that's because there's only 15 students. If a particular good 15 students apply, the points rocket. Okay? The other thing I'd say is that these courses are essentially, they're like entering science except deciding what your third and fourth year subject is from day one. So all of these subjects, the higher points doesn't mean a higher quality course, as some people seem to think, because these are all based on science modules. They're the same modules. You'll be in the same lecture theatre if you do nanoscience as the physics and chemistry students. So it doesn't, the idea that points means quality is not true. If you're looking to science, if you're not quite sure what you want to do, then the common entry is definitely the choice for you. It may well be the choice anyway. So, hopefully I haven't confused too many people. This is the presentation schedule. I'm done now. I just wanted to explain to you the different aspects of the science course, particularly the choice. There's talks from different disciplines within science all day. There's also the stands down the far end of the atrium. Okay? There you will have representatives from each of the schools and departments associated with science who will be able to answer detailed questions about the particular subjects. Okay? And finally, I think we're still operating it. There's a one-way system in a sense. Can you please leave the lecture theatre through the exit at the front here? It will cycle you round and that prevents congestion on the way.